This is your chance to dive into the heart of manufacturing. This is your chance to hear about company culture and people making an impact in the industry. This is your chance to join the conversation with host Jim Mayer in the Creators Lounge.
The Creators Lounge is proud to welcome ESTAT.
Hello and welcome back to the Creators Lounge. Today I've got not one but two very special guests, and we're going to talk about some technology that is absolutely mind-blowing to me. I saw it the other day at the booth. I'm really excited to talk to you two about it. I'm joined by Kirby Witte and Stuart Diller. Gosh, I'm starting to nail these last names, man. This is great. So, Kirby, Stuart, thanks again for joining us. I start all of my interviews, whether we're in the Creators Lounge or on either of my shows. I want a quick background on you guys. How did you end up on the white couch at IMTS 2024, sharing your product, sharing your story? Kirby, let's start with you.
Sure. I completed my PhD at Carnegie Mellon University, where I studied exoskeletons. So designed exoskeletons for helping people run faster or recover from stroke.
Okay.
I saw that actuator technology was too big, too bulky, too power hungry. So I decided to get out of exoskeletons and get into surgical robotics.
Okay.
But it turned out that we had the same problems there too. So my experience putting people in robots and robots inside people gave me an appreciation for small actuators, and I knew Stuart from our time at Carnegie Mellon.
Wonderful.
So I called him up to see if he had any products to solve my problems, because I was familiar with his research at the time, and he said, no, but I'm hiring. And I saw the power of the technology that he was developing and decided to join the company. And I've spent the last 4 years taking Stuart's research and translating it into useful products, and we just launched our new ultra slim brakes, and Schneeberger North America became interested and invited us to IMTS, and that's how I got connected to the Creators Lounge.
That's awesome. And I do want you to kind of show us that. But first, Stuart, how did you get into this seat here?
Certainly. So I also did my PhD at Carnegie Mellon. This is where I met Kirby, so we've known each other for over 10 years now.
Very cool.
And
good connection then.
I came because I was really excited about building wearable robotics, exoskeletons, soft robotics, but quickly encountered the same problem. You need things that are really lightweight, really power efficient, don't heat up, that make you hot when you wear them. So we explored a lot of different kinds of technology, landed on this, and it's the one that stuck, pun intended.
I like that. That's good. You should only use puns if they're intended.
Yes.
Right? I don't like it when people use puns and they're not intended.
It's the coward's way out.
It really is. It really is. So, Kirby, ESTAT Actuation, talk to us about the 4 products you have in front of us today.
Sure. So at ESTAT Actuation, we make electric glue. And we build that electric glue into the world's most compact and power-efficient brakes, clutches, locks, and latches. Okay. So the product that we're showing off today at IMTS is our ultra slim linear brake. So this is a brake that is only 0.4 millimeters or 15 thousandths of an inch thick. You also don't need any special tools to install it. You just peel the adhesive off the back and apply it to whatever machine you need a linear brake on. Our more traditional products are our rotary brakes. So this is the first product that ESTAT started offering about a year ago, actually. So a year ago, we had one rotary clutch for sale as an evaluation unit. Now we have a catalog of over 20 configurable clutches, in addition to the linear brakes as well.
Wow. So does the ESTAT also still do exoskeletons, or are you focused 100% on this brake?
No, that's a great question. We're actually in the middle of a project with the Air Force developing a neck exoskeleton for fighter pilots.
For G-force?
For G-force, yes, a huge problem that pilots face is that they wear heavy head-mounted equipment like heads-up displays, night vision goggles, helmets, those kinds of things. And that shifts the weight of their head forward and up, which puts a lot of strain on their neck muscles. So we actually have a shortage of pilots right now because they experience so much chronic neck pain from supporting that head-mounted load. So the exotendon system that we're developing for the pilots will counterbalance that weight to prevent the chronic injury, and then in event of ejection, it will also lock and redirect the forces from the head to the body to protect their neck from spinal injury during ejection.
Oh my God.
And the reason that we were selected for this project is that we make something that is so light, so thin, and so power efficient that it can be worn in a cockpit without interfering with any of the other equipment around the pilots.
So does that have similar properties to this as far as size, scope, et cetera? I mean, electromagnetic glue is how you put it earlier, right?
Sure, electrostatic glue. No, you're fine, you're fine. Not very many people are familiar with electrostatics, but yes, the exotendon system actually uses the same rotary clutches to achieve the various modes that it's in. And it's really the clutches that are the enabling technology, has no motors, just engages and disengages springs to achieve the different modes depending on what accelerations the pilot is experiencing and how fast their head is moving.
Wow, that's astronomical. Stuart, you started this company. How did you find a passion or a love for this?
Yeah, so I think I built up the passion for entrepreneurship, for having an impact in the field through a lot of really good mentors and connections, particularly around the Pittsburgh area. That's
Sure.
where our company is located, including Carnegie Mellon, the Pittsburgh Robotics Network, Innovation Works. I mean, the list really just goes on and on of people who helped me cast a vision for the kinds of impact that we could have in the industry and the kinds of impact that we could have in the Pittsburgh area.
Wow, that's amazing. Some of the smartest people I've ever met came out of Carnegie Mellon, and that's like that little known secret of Pittsburgh, I think. We're going to come right back after a sponsored break. Ladies and gentlemen, we'll be right back after a break from our sponsor.
Everybody in the 313, put your manufacturing hands up and follow me, because we're going to season 3 of Road Tripping with Steve. This is awesome. I've never been in an automotive facility like this. Hello? Hi, this is Road Tripping with Steve. I need to leave and go let my head cool down. The Robo Drill is seriously one of my favorite machines.
Brand new program, call it whatever you want.
Steve's program.
All right.
Can you take it past 100%? Do it again.
Hello and welcome back to the Creators Lounge. Again, I'm with Kirby Witte and Stuart Diller of ESTAT Actuation. I'm not used to sitting in this chair, so I actually get to point to your logo, which is kind of fun for me today because typically I'm right where Kirby sits, and I like this chair. This is Amy's chair. I want this chair more often. Amy, I'm coming for your chair. Stuart, tell us what electroadhesion is, because I don't know if many people know what that is outside of your community.
Certainly. Well, it sounds complicated, but it's remarkably simple. So basically, if you take two electrodes and separate them by an insulating material and apply a voltage across, they attract one another because you have positive charge on one side and negative on the other. So what we've done with our devices is essentially we create an interface right in between that dielectric, where now you can have parts that move relative to one another, but then they stick once you apply that voltage. And when you remove the voltage, they unstick, and that's how we get that controllable glue effect between surfaces.
Wow, that's amazing. And I do have to make a little correction. I've been introducing you as just Kirby Witte. You are Dr. Kirby Witte. So I do need to correct myself. Are you also a Dr. Stuart?
Yes, I am.
So I will refer to you both as Doc from here on out. Just kidding. Dr. Stuart, Dr. Kirby, I apologize.
Oh, no worries.
No worries at all.
Kirby, let's go back to you. I want to talk about what are some other applications for this electrostatic adhesion principle. We were talking in the break there for a minute about something that made my jaw drop and our producer's jaw drop. So tell us about that.
Sure, we see a lot of traction in exoskeletons, wearable robotics, medical robotics, but we also do a lot of work in aerospace. And in fact, these paper-thin linear brakes were first developed for shape-shifting airplane wings in a project in collaboration with the Air Force Research Lab.
Wow.
So designed for shape-shifting wings, has application in manufacturing.
Absolutely. What else could we make shape-shifting? I mean, as far as manufacturing is concerned, when we look at the manufacturing ecosystem, I could think of a lot of things that I just could dream up that I'd love to watch shapeshift. What are some other applications that we could think of that may be out of the box?
Oh, sure. No, that's a great question. On the simpler side of things, modularity. So if you want to reconfigure a tooling setup or reconfigure a station, you just simply remove the components and reconfigure them however you want.
Wow.
But I really like the idea of, I have a background in race cars. I was in the motorsports team during college, and I actually think that we could be making shape-shifting molds for airfoils.
Wow.
So that would be kind of the inverse of the shape-shifting wing, would be shape-shifting molds so you can achieve different shapes without new tooling.
That's awesome.
And I'd say anywhere that you have things that are vibrating that you don't want to be vibrating.
Okay.
You can build this in to enable the kind of functionality you need to be able to move around, but then if you want to lock it in place and it's sitting there vibrating, you can incorporate some of these devices to stiffen it up controllably.
That's really cool.
And that was something that we saw on the shape-shifting wing project. We were able to reduce the energy consumption of the electric actuators by 66%, but also the wings were experiencing wingtip flutter. And that happens when the wind is exciting the natural frequency of the wing.
Sure.
You change the stiffness, you shift the natural frequency, you stop the flutter. So if you want to change the stiffness of basically anything you can adhere one of these clutches to, you can. And then also in manufacturing, you're often holding a position to perform a task or take a measurement, and how precisely you can hold that position is determined by how good your motor control is.
Sure.
So instead, you just apply these brakes and hold the load directly. So you can get much better precision holding using these brakes as you would with just your motor alone.
Wow. And so is that where this concept with rotary clutches has come into play? I mean, I'm punching above my weight class here, even having this conversation with you guys, but I'm trying. Rotary clutches, is that a use case for these moving components into position and things of that nature?
Absolutely, yeah. So in the case with our collaboration with Schneeberger putting together this demo, there's a benefit to having brakes on the output side of your gearbox because you have lots of potential backlash, lots of low stiffness components potentially. So being able to put these, either a rotary brake or a linear brake, onto the output can provide that value.
Wonderful.
Yeah, no, anytime you need to control motion, you usually need to stop motion as well. So if you are in the motion control business, you can benefit from our brakes either for higher stiffness connections or lower energy costs or space savings or weight savings.
That's awesome.
In fact, we're 1,000 times more energy efficient than an electromagnetic option.
Wow. So you guys are all about creative problem solving, right? That's kind of your logo, right? That's all you want to do is just create solutions for problems that are out there. Talk to us about the future of what those... One second, let's take a quick break because I want to get into that pretty deeply. Let's take another sponsored break, folks. We'll be right back after this message.
watching The Creators Lounge. Gain insights as our hosts talk to expert guests about key industry topics. Come see the action live on the trade show floor. Visit booth 338 600. See you at The Creators Lounge.
Hello and welcome back to the Creators Lounge. I'm here with Dr. Kirby Witte and Dr. Stuart Diller. Before we jump to break, we started talking about what the future looks like for ESTAT Actuation, because you guys are in the business of solving problems and with very creative, very smart solutions, practical solutions. What's the future look like?
This is a very exciting time for us as a company because we're a university startup and we're transitioning to growth company.
Wow.
So some of the problems that we actually have to solve are our own. Thank you. These rotary clutches I have with me today are very close to my heart because they're the first that we produced with the roll-to-roll manufacturing process.
Wow.
So the first problem we have to solve is learning how to scale production now that we're getting so much traction. And we have a upcoming fundraise. So if you're an investor out there listening, please get in touch with us at info@estat.tech to talk about investment opportunities that are coming up. But as far as the products go, we're just excited to have the rotary clutches available, the linear clutches, and to see where our customers are using them, whether it's for tool holding, fixturing, motion control, or whatever they see a use for electric glue.
That's awesome. Yeah. That's awesome. Stuart, as CEO of ESTAT, talk to us about the mindset that you have going from that university student-run business, basically, to this new chapter of the organization. I mean, this is a monumental step that not a whole lot of organizations in your position have been able to make and even have the ability to make this next step. Talk to us about that mindset, how you're going to build out your team, everything.
Yeah, I'd say the two biggest things that are hard to do, transitioning from working in academia, doing a PhD, getting to a business, are first focusing on the customer and not the technology, right? So really getting out there, doing the customer discovery, coming to trade shows like this and talking to as many people as possible.
Sure.
This is really where we learn the most important things about the market and about the customers.
Yeah.
I'd say the second thing is hiring a team and getting really great people. So shout out to the ESTAT team back at home that we have.
Yeah.
But it's easy when you're a PhD student to think I'm doing everything myself, right?
Right.
And so as you transition to having to do 10 things instead of just one thing with the company, you really learn quickly the importance of having the right people and the right kind of organization to be effective.
I love it.
So we're definitely learning on the job, but Kirby's a great partner in that as well.
Yeah,
Awesome.
and I want to give a direct shout out to Max Lindsay, our product manager, who is filling the largest order we've ever taken in right now. And so Stuart and I are excited to be here at IMTS and are glad that we have such a great team at home taking care of business.
Wonderful. And how big is the team?
Yeah, we're about 10 people right now. 5 full-time. We are hiring, like you mentioned, so we're bringing in some additional key technical roles, but then expanding out into some additional business and project management roles as well.
Is there a different website that people can go to apply for a job?
ESTAT.tech/careers.
Okay, wonderful. Anybody out there who's looking for a career with, let's say, game-changing technology, right? And this is part of what I love about manufacturing is people have historically thought that they're making widgets. This is game-changing technology that you guys have created here and that you're moving into a manufacturing scale environment. I could see that being something that really starts to attract some of the best and brightest in the world of manufacturing. I'm super excited for you guys. I think you're going to both do great. Any last parting words, anything that I did not ask you today that you'd like to convey to the audience?
I always ask this question when I'm talking to people too, and never have an answer myself.
I have something, and that's that bringing ESTAT from 3 people in a garage to where we are now with our own office and contract manufacturers has been just the greatest joy of my life. And it's also very exciting because prior to ESTAT, each system I developed took years to develop and felt very isolating. But now we have the opportunity to touch hundreds, if not thousands, of different systems, thousands of different people. And this is what's really exciting to me, is to be able to really make an impact in a widespread way.
Amy, I hope you heard that. Our word of the day this morning was impact. And talking to people throughout the show about making an impact in this industry. Dr. Kirby, Dr. Stuart, I am so thankful to have had this opportunity to talk with you today. Thank you so much. Enjoy the rest of your show.
Thank you. It's a pleasure to be here.
Yeah, thank you, Jim.
Thank you for joining us on the Creators Lounge. We'll be back with another episode.